Okay, today we are looking at determining the independent and dependent variable, and we are working with story problems that are going to cause us to have to complete a math model, and it's going to be looking at or involving, it's going to be involving area, perimeter, perhaps volume, and in this one I'm looking at it and we're going to be dealing with area and volume. The first thing I want to do is read my problem and try to make sense of it. It says, Mo is building an aquarium. She bought a base for the aquarium that has an area of 3 square feet. She is considering a few different heights for the aquarium. She made a chart to help her decide what are the independent and dependent variables in this situation. Okay, so let's kind of make sense of the problem. You can imagine she goes to the store, she goes to the pet store perhaps, and they sell her a base for her aquarium, and her base, it tells us it has an area of 3 feet squared, or 3 square feet. I'm going to imagine that her base, the length of it is, well, the width is probably 1 foot, and the length of it's probably 3 feet, so it probably is 1 by 3 feet. And she can determine how high up she wants her aquarium. So what she's probably going to be doing then is she's going to, give it a height to her aquarium, and it's going to look something a little bit maybe like this. I don't know. This would be like the base of it, the bottom of it, and this would be like a little aquarium, and then there's a little fish in it. Anyhow, if the aquarium is 1 by 3 feet, that's the base, and the height in this case, and we'll say this here is the height, is 2 feet, then when you look at this problem like this, 1 times 3 times 2 is going to give us 6 feet cubed. 6 feet cubed. So she can work with the height. Now, depending on the height of her aquarium, her volume is going to change. So her volume here, the V, is going to be the dependent variable, and her height is going to be the independent variable. Because the volume is going to depend on what the height and the area of the base is. So let's go ahead and keep going. So here we have this formula. Let's talk about formulas. Now, usually when we have volume, we think volume equals length times width times height. But here they've got the base for us, and the base is simply the area. It's the length times the width. So we're looking at a formula like volume equals base. Capital B is the variable we'll say for base, for the area of the base, and times the height. Now here we've got 4 feet as the height. So 3 times 4 gives us 12 feet cubed. And then 3 times 6 gives us 18 feet cubed. Now if I were to talk about math practice here, I would say number 4 that I made a math model. And that's essentially what my chart here is. My chart is my math model. Now, does anybody have any questions about what I've done so far? Any of my students in here? Okay, Brandon, what's your question, young man?
Why would the height be the independent? Why couldn't it be the area of the base?
Well, see, the area of the base is also an independent variable. That would also, of course, if it was a variable, if we had a variable for it, well, this value, we'll say this value is independent. I mean, the area of the base, the height, they're the independent variables, because when you look at it this way, here you have like two factors, and this will be our product. And your factors are always going to be your independent variables, and your product's going to be your dependent variable, because your product depends on the value of the factors to get its value. Does that answer your question? Now, I just didn't identify the area of the base as the independent variable because she was able to adjust the height. She cannot adjust the base. The base is 3 feet squared no matter what. She bought it at the store. She cannot change that, but she can determine how tall up she wants her aquarium. She can determine if she wants it this high. And I apologize that my drawings are not that great, but anyhow, she could she could affect that, the height, but she cannot do anything at all about the base. The base is gonna be 3 feet, you know, it's all about that base. It's all about that base here. All right, does anybody else have any questions? Nobody? Okay, what's your question, Morgan?
Instead of drawing a model and finding out that the volume would be 6 feet squared, couldn't you get 3 feet squared times 2 feet, which would be 6 feet squared? I mean cube.
I'm sorry, are you thinking that this is my model here, the aquarium I drew here?
Yeah.
No, honey, that's not really my model. That just helped me make sense of it. Okay, that was just a little something to help me make sense of the problem. My model is actually that chart. Now, I'll go ahead and erase this because I mean this was just something that I put there to make sense of the problem. You know, here she's got a base. It's a little plastic thing, and then you're going to fit the walls of the base. And I apologize. This slate does not let me draw the way I would want to. So I mean that's just what and I cannot do it any better than that. I don't need the drawing after all. I don't. You could just say, the chart itself is my model. This is my model. You know, I use this model, this chart, to help me, write down the volumes of the aquarium. Okay?
So you could just multiply it.
Yeah, you could have just, I could have just said 3 feet squared plus, times 2 feet gave me 6 feet cubed. 3 feet squared times 4 feet gives me 12 feet cubed. 3 feet squared times 6 feet gives me 18 feet cubed. Okay? All right, now, how many of you feel pretty confident that you could do problems like this? All right, that makes me feel a little bit better. Good.